All right, as we look at the rest of 622, we're looking at number 69. A lemon skate looks like an infinity symbol, and here's its equation. Kind of a cool function there. Picture trying to solve for y here and getting it, by itself, or trying to find the derivative. That I think is not really doable. So to algebraically find the slopes, now again we can estimate them. I would say they're not going to be 0, but they might be close. Looks like one's going to be slightly positive, one's going to be slightly negative. But I think implicitly deriving this equation would be one that I would put very specifically in my notes, and I would refer back to or try again several times on my own. So let's go ahead and try it. I've got 3 times this function squared, or this relation squared. So the first thing I'm going to do is that power rule. So 2 times 3, 6, x squared plus y squared to the 1. Then I've got to do the derivative of the inside, so that chain rule. 2x plus 2y times dy dx. And that's the whole left side. The right side's a little easier. I've just got that 25, and then I've got the 2x minus the 2y dy dx. So then we can try to get everything with a dy dx on one side, everything else on the other. So we've got to do probably some distributing for sure. Let's take a look at that. I'm going to choose to leave this as kind of one piece here. So I'm going to say this piece times the 2x is going to be 12x times x squared plus y squared, plus this piece times this guy here is going to be the 12y times x squared plus y squared times the dy dx equals, this side's a little easier, 50x minus 50y dy dx. So now we can kind of see our 2 dy dx pieces, and we want to get them on one side. So I'm going to add the 50y dy dx over. I'm going to subtract this guy over. So I'm going to have 12y x squared plus y squared dy dx plus the 50y dy dx equals, this guy gets subtracted over, 50x minus 12x x squared plus y squared. I'm really close. I'm going to factor out the dy dx. I'm going to do this in one step. And then I'm going to divide by what it was factored out, 50y plus 12y x squared plus y squared. I don't think there's really any simplifying we can do because of the pluses and the minuses. But I've definitely got my derivative now. To find the slopes of the tangent at x equals 2. So I can put in the x equals 2, but I also need to put in a y value. How are we going to decide what the y value is? I need to put the x in here and find what y value is. So 4 plus y squared equals 25, 4 minus y squared. So I think the easiest thing to do here is probably expand, solve for y again. So let's go 16 plus 8y squared plus y to the 4th equals 100 minus y 25y squared. Getting closer. I'm going to start rearranging here. 3y to the 4th. I've got this plus 24y squared, and I've got to add a 25y squared. So I'm going to get 49y squared because of that. And I've got this 48, 3 times 16 is 48, minus 100 is going to give me a minus 52 equal to 0. Now I can use my quadratic formula, or just factor, I think, and solve for y. And as I factor that, I think I get 3y plus 52, y minus 1. So y equals negative 52 thirds or 1. And so, to find the slope as x equals 2, I need to put a 2 in for x. And I need to put both of those values in for y. So I'm going to get two different answers. I think when we plug those values in, we get plus or minus 2/11ths for the slope. Now that's a pretty advanced problem.
What are you talking to?
We're making a calculus video.
Is it more a video?
It is. Yep. All right, guys, stop sniffling though.
Why?
Right. Not only is the derivative of this limit skate not a function, it does not exist at two places. Explain. It would not exist when we set that equal to 0 because we can't divide by 0.
Because we can't divide by 0.
Exactly. And then if we solved... So, as I was solving that problem, I would probably say, I know that the derivative doesn't exist when we have a vertical tangent line, and the value of y there is 0, so I could actually put a 0 in for y and solve, and I think I would get, this x value of somewhere around, looks like really close to 3, 2.9. That makes sense. And then number 70. Consider the circle x squared plus y squared equals 16. To find the first and second derivative, well, I'd probably go implicitly. 2x plus 2y, y prime equals 0. So in this case, y prime equals negative 2x divided by 2y, so it's just going to be negative x over y. And then the second derivative, we're going to have to use the quotient rule. Bottom d top minus top d bottom over bottom squared. And again, when we do something like this, we want to resubstitute what y prime was. So the second derivative would actually be, let's go negative y plus x times negative x over y squared. Something like that would be a little better. I don't think that was too tough. Let's get started on some homework.